Good morning, Ms. Wicks.
Good morning.
How are you today?
I'm doing pretty good.
That's good. So we are going to go over Unit 3, Internalization.
Okay.
And with Unit 3, Internalization, we have the assessment that you are going to use for Unit 3, which is the chemical bonding.
Right.
And so before we get ready to go in, can you share some of your key ideas of the module with me? And while you're doing that, I'm going to pull up your internalization sheet, okay?
Okay. They really need to have a good understanding of ionic and covalent bonds and how electrons behave in both of those, whether they're being shared or transferred. And then they need to have a good understanding of the shape that molecules and compounds can form in these bonds, because when they get into double or triple bonds and polarity of molecules and compounds, that changes the shape. So we're going to do quite a bit on molecular geometry, and that is going to take us to the end of the semester.
So what I heard were the two key big ideas for this unit is covalent bonds and the shapes of bonds, which goes into the molecular geometry. Okay. From there, and looking at the up and coming assessments, what do you think the students need to be able to? What do you think the students need to be able to do to master covalent bonds and the shapes of bonds using the molecular geometry? And go ahead and name 2 to 3 key points of mastery.
They are going to have to be able to look at a formula or a Lewis dot structure and be able to understand the 3D shape from a 2D drawing. They are going to have to understand where bonding will occur on a molecular compound, and things don't just attach anywhere that they want. And they're going to have to predict where bonds will happen on Lewis dot structures. And then they need to be able to take away ideas about the strength of these bonds that have formed based on shape.
Okay. And so going through the formula, the 2D and 3D shapes, when the bond will occur, and the strengths of the bond based on the shape of the bond, what predictions do you have as far as the misconceptions students may have? And so like going into conceptually thinking, so the thinking steps that they may have misconceptions with. Okay.
I think visualizing a 3D shape is going to be difficult, just from the struggles we had with electron configuration and visualizing the shape of orbitals. So that, I think, is going to be an issue. I think they're going to have...
Can I ask another question?
Sure.
So when you, and I thought about the orbitals too, as a piece that they may have, the misconceptions may occur most. Why do you think the students may have the most error with observing and knowing the orbital status?
From what we did previously, I think it's a very abstract idea, and traditional models of electrons show them in a very circular pattern, they're traditional shell diagrams. So we introduce that first, and students kind of grab onto that. And then when I try and switch it up and say, okay, let's think about this a little bit more abstractly, they don't travel in a perfect circle around the nucleus. They are found in different locations, and then just trying to take that thinking and that idea to the next level is difficult. And I just don't know if it's a lack of exposure. Like this, for most students, is the first time they've encountered this material. And just trying to have a better way of modeling it, I think.
And so and that's the key point, so them not traveling in a perfect circle around the nucleus, right? The nucleus has all this information that the object will, or the bond, or the covalent bonds have. And so when you think about what do you think the thinking steps are for students to not understand? What is the gap between the thinking step for students to not understand that it doesn't travel in a perfect circle? The orbital does not travel in a perfect circle.
I think they need to understand that at a subatomic level, those electrons are really more like particles of energy almost, rather than like a solid thing like a planet or something else that travels by gravity versus traveling through energy.
Yes. And so going into that misconception, I think when thinking about that in particular, you can take notes too, meaning like definitely stamping, hey, this is energy, right? And energy does not travel all together, right? Because it's not a specific object, right? So it's not like we have energy around this cup, right? We're picking up the cup, but it's energy at the bottom of the cup, it's energy at the top of the cup, it's energy around the cup, but we cannot see it with the naked eye. But energy is forming all around this cup, meaning it's not performing in a perfect orbital circle, it's around the item. And that's kind of like the kinetic energy, and going into that, just stamping this atomic energy that is around the object. Because they'll think, oh, it just happens, right? And so energy is in this computer, around the computer is how we move our pens, our pencils, it's not seen. So it's not always moving in that circular motion around the object, but it is there. Okay?
Yep.
And just stamping it. I mean, it's simple to stamp it like that, but just for them to get, oh my God, energy is everywhere. Energy is when we're walking. The movie that I do like, I can't remember the name of it, I don't know if you saw it, but it's about a boy and a girl best friend, and they're trying to create a time machine to go back, and then it's by Spike Lee, and they end up going back, and then she changes time with the energy that she creates. Yes. I want the kids to, because I know some kids have watched it and some kids haven't, but just even the energy that they use to change their time, actually their physical self in time, and how it just didn't circulate around one object. There was multiple things involved. Yeah. Which would be cool if they can get a little snippet of it. And we can kind of include that, like a little snippet of it for homework. Because I think it's kind of like a cool experience to show them like how energy works and how it's not just circular and it's like basically everywhere in the room that we're standing in, but we just can't see it. You got any questions for me so far?
No.
Okay. So now, when you went through your multiple choice and you have your assessment tagged in the, actually right here, in the unit, which questions did you think that the students would have the most troubles with, and then I'll tell you as well. Okay. We can kind of like spar going back and forth.
Sure. I thought that they would have the questions related to Vesper theory, VSEPR theory, are going to be challenging because then those require.
What question are you on?
Like number 4.
Tell me a little bit more. I didn't have 4, but go ahead and tell me.
I think just understanding the concept of that theory is going to be challenging, because that's where a lot of the geometry comes in, and if they like don't understand what shape is associated with that name, then they're going to have difficulty just answering the question. So we're going to have to spend some time just building an understanding of those vocabulary, the geometry vocabulary.
I think this is so, even looking at the question now and thinking about the theory, which statement is true about the molecule? And so even them understanding the 3 bonding domains and the one non-bonding domain.
Right.
And so definitely so going back to the vocabulary, right?
Right.
And then also to them revisiting their chart. And so even going through the chart and seeing what misconceptions the student has with their charts, because I know they did a lot of work with their the bonds and the atoms and electrons, but I think if we don't address the misconceptions they have with the chart, then this is where they will continue to fail, even when we give them the necessary vocabulary and language for the 3 bondings, so in non-bonding domains.
Okay.
Yeah. How about we go in the order, you give me 2 and then I give you 2? You wanna do it that way?
Okay. Yep.
Okay.
Sorry, I was just trying to.
Oh, no, go ahead and take your notes. And let me know if we're going too fast too, okay?
Okay. I think for some of them, drawing the Lewis dot structures, especially with the bent bonds, is going to be a trouble.
And when you think about the trouble, right? And that trouble is a misconception. So what do you think the exact misconception that is going to affect them the most with the Lewis electron dots?
I think understanding polarity is going to be what trips them up the most, and just how to assess whether that element is going to be positive or negative, and then how that how that's going to affect how they draw, whether it's like 2 straight line double bonds, or if they need to go at an angle, because there's quite a few steps that you have to go through in order to make sure.
So you have with the Lewis electron dots in the structure, right? So you have your conceptual thinking, right, and you have your procedural. And so conceptually, what do you think the error will be? Like their thinking steps.
I think they're either going to leave polarity out entirely, or they are going to get confused about which side of the periodic table tends to be more negative, which side tends to be more positive. So the thinking steps for polarity, right, and understanding polarity, and so that's going into the conceptual. And so now, procedurally, them actually looking at their table and seeing which side is more negative, which side is more positive. And so, do you think those are the only 2 procedural things that they'll have the gap in? I think still going back to valence electrons, they don't have that memorized yet.
And do you think, what about covalent bonds?
With the sharing, I think they're going to have an issue with drawing in where that sharing is going to occur.
And so when you think about the misconceptions and think about the questions they'll have the most trouble with, right? And even with us just picking out, well, you just sharing those two questions, right? And those two questions mean so much within chemistry, right?
Right.
And so to even master those questions, you have to know your atomic number. You need to know what is a covalent bond. You need to know of the valence and the balancing of them and the Lewis electrons and the bonding of it and the non-bonding. And so even just these two questions on the assessment can bring you to so much, it can be so impactful because those are the steps procedurally and conceptually they need for all of this entire unit.
Yeah.
Mm-hmm.
It is.
Questions for me before we go on?
No.
Okay. And so before we go into our next question, well, our next section, what thinking step, well, we talked about the thinking steps, right?
Right.
And so how many lessons do you feel like you are going to need to get them to mastery before the taking the assessment?
Right now, for the unit, there are there's 13 lessons
Mhm.
that go all the way up through intermolecular forces,
Mm-hmm.
and we have a lab on chromatography,
Mm-hmm.
which is on intermolecular forces. And then the rest really was kind of flex days with some data-driven instruction days based on how they're doing on exit tickets and a few little mini quizzes that are built in, and then some like flex ACT practice days.
Okay. And so we have the 14 lessons and then we have only one lab?
No, we have some other kind of smaller labs that are built in, and we're going to be doing some things with the model kits that we have, which I think will help them get a better visualization of the geometry. It's really hard on a macroscopic level to do a lab that shows bonding occurring.
Yeah. We could, so,
Like there's lots of labs to do on intermolecular forces and like the strength and that are easily observable.
What do you think about doing a virtual lab?
I'm doing a couple of those now. I find that they kind of go through the motions to complete the activity. I think I need to come up with more.
Make it more purposeful?
Yeah.
So even with the virtual labs, and this is straight up going off cue, just brainstorming like virtually we're doing this portion of the lab together, and then we're taking our lab notes, then we're reporting, right? You pick cold call 1 or 2 groups to share out their findings.
Okay.
And then you go into the next section. Instead of like, hey, we're just gonna rush through, like you're actually following your lesson guide, like I do, we do, you do.
Okay.
Because we have enough computers for them, even if we do 2 Chromebooks for them to do it individually instead of groups, and then they can combine as groups after they've all completed the task. You get what I'm saying?
Right. Yeah.
To make it more purposeful.
Okay.
And so that kind of like takes us into our planning cycle. So with this, thinking about adding more labs
Okay.
that are virtual, that you can do the I do, we do, you do, and still give them the time to have the at-bats, right? And then them to actually be able to share out and think and share their thoughts with their peers, and then you come together and share it again. So think about that, and then excuse me, the reteaches. And so thinking about when you are specifically looking at polarity, the Lewis electrons, and even kind of like going back to covalent bonds, You kind of like insert those reteaches in there